Hi, I'm Patrick Reagan. Welcome to Network Security, Part 1, Security Fundamentals. During this video, we'll discuss basic network security terms and concepts that is essential for any area in IT, not just networking. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the Network Plus exam. If you find this video helpful, don't forget to click the like button, and if you have not already, subscribe to the Pat Hedger Back channel for more tech training content and technical know-how. Security is often in the news. Everyone is at risk of the data breach or cyber attack, no matter how small or large a company is. Even individuals are at risk. Security breaches are becoming more common. If you don't believe me, just look at the sites shown on the screen for some recent breaches. If you look through your emails, you could probably see cyber attack attempts every day. Cybercrime will cost business billions of dollars each year, and millions of data records are exposed worldwide each quarter through data breaches. Security involves the protection of information systems and the information processed, stored, and transmitted by these systems from unauthorized access, use, disclosure, disruption, modification, or destruction. Since complete security can never be fully achieved, the focus of security is more often the process instead of the goal. As security is increased, convenience is often decreased. You need to find the sweet spot between security and convenience, and if possible, look for invisible security. And lastly, security costs money. When looking at security, here's a starting list of what you must consider. Physical security. Security that allows access to a building, room, or data center. Network security. Protect the network from unwanted users, attacks, and intrusions. Endpoint security. Protecting the client computers and devices that are used to access your resources. This also includes security for mobile devices. Besides computers, users will use smartphones and tablets to access organization resources. Data security. Protecting information. Identity management. Understanding and protecting how users prove who they are and how they access resources. Database security. How to protect databases which stores, organizes, and retrieves data. Infrastructure security. The physical equipment including servers, firewalls, routers, switches, and gateways. Cloud security. Many services and resources are hosted by third-party companies which are accessed over a TCP/IP network, including the internet. And disaster recovery and business continuity planning. Plans, processes, and procedures that you use when a disaster occurs that causes an outage, a degradation, or a breach so that you can keep functioning. CIA represents a model that represents the core goals of an information security program: confidentiality, integrity, and availability. Confidentiality is data is only available to authorized parties. When information is kept confidential, meaning that it has not been compromised by other parties. To support confidentiality, you need to have strong encryption. Encryption is often associated with confidentiality as it prevents unauthorized people to read a message or data. Strong authentication, and stringent access controls. Confidentiality also includes the classification of data, where you categorize the data and assign labels. The classifications are used to determine the appropriate protections for the data. Some examples of labels are public, internal use only, confidential, and strictly confidential. The military might use unclassified, restricted, confidential, secret, or top secret. Integrity is defined as the consistency, accuracy, and validity of data or information. It ensures that data is protected against any unauthorized or accidental changes. It ensures that data has not been tampered with or corrupted. Checksums and cryptographic hashes are associated with integrity, which can show if a file or message has been tampered with. Transaction logs and audit trails track changes to data and systems so that you can detect and correct any unauthorized or improper changes. A security program should include policies, processes, and procedures to manage intentional changes, including a change control process, as well as the ability to detect changes. Availability is ensuring that resources are accessible to a user, application, or computer system when required. In other words, availability means that when a user needs to get information, he or she has the ability to do so. Threats to availability come in two types: accidental, which includes natural disasters, equipment failures, unplanned work, and honest mistakes by people. Deliberate, usually done by exploiting a system vulnerability. It includes a denial of service attacks, including overwhelming a system or even cutting of a cable, and malware. To ensure availability, you should deploy redundant systems and use load balancers. You should establish business continuity and disaster recovery plans and perform a business impact analysis or BIA. You need to establish recovery objectives or RTOs and recovery point objectives or RPOs for backups and recovery. You should test failing over systems. And lastly, you should establish service level agreements or SLAs for uptime and availability of services. AAA is short for Authentication, Authorization, and Accounting. Authentication is the process of identifying an individual, usually based on username and password. Authorization is the process of giving individuals access to system objects based on their identity. Accounting, also known as auditing, is the process of keeping track of a user's activity while accessing the network resources, including the amount of time spent in the network, the services accessed while there, and the amount of data transferred during the session. Non-repudiation is the assurance that someone cannot deny the validity of something. Non-repudiation provides evidence of data's origin, authenticity, and integrity. It verifies the sender that the information is sent and the recipient's entity to the receiver. If proper authentication, authorization, and accounting have been established, a person cannot deny their own actions. Examples include a user is authenticated based on multiple factors before performing a transaction. A user signs an email using a private key that proves that the user is the only one that could have signed it, which proves that the message came from the user. Defense in depth is a strategy that leverages multiple security measures to protect an organization's asset. Multi-layered and multifaceted. If one layer of defense is compromised, the deeper layers of security are there to maintain protection. It must have diversity of defense. Depth is commonly referred to as the castle approach because it resembles the layered defenses of a medieval castle. This figure shows some of the security mechanisms used that provide layers in security. Physical security is essential since if a bad actor can get to a computer or other resources, the bad actor can take down the computer resources, causing a denial of service or steal the computer or components, and the chance of access confidential and proprietary data go up significantly. Physical security protects physical assets, personnel, and facilities from worldwide threats like theft, vandalism, and natural disasters. It controls who can enter a building or touch a server. Examples include fences, barricades, bollards, gates, locks, guards, man traps, and sensors, which include motion detection, noise detection, moisture detection, and temperature detection. Physical security refers to the entire building and should not be restricted only to the front or main door. Logical security refers to software-based safeguards, protocols, and policies designed to protect digital systems, data, and applications from unauthorized access, cyber threats, and misuse. It protects digital information, software, and networks from virtual threats like hackers, viruses, and unauthorized data access. It controls who can sign into a system or view a file. It includes authentication and authorization, passwords, multi-factor authentication, firewalls, and access control list, encryptions, and patching of systems. Some examples that are both physical and logical security include biometrics, smart cards, hardware security tokens, and radio frequency ID and NFC fobs, mobile devices used to provide a form of multi-factor authentication via the Authenticator app or use NFC to open a secure door. Remember, physical security restricts physical entry, while logical security restricts digital access. Segmentation divides a network into multiple segments or subnets, each acting as its own small network. It allows network administrators to control the flow of network traffic between subnets based on granular policies. Smaller networks allows you to set up security boundaries, which increase the number of security layers. Segmentation can provide threat actors who have gained access to a network from moving around within the network. The safest network is one that is totally isolated from other networks. Here's an example of how you may divide your network into smaller subnets. Least privilege, or principle of least privilege, is a security concept requiring that users, systems, and processes be granted only the minimum access rights and permissions necessary to perform specific authorized tasks. No more, no less. It restricts users' permissions to the absolute minimum, significantly reducing the attack surface, mitigating insider threats, and minimizing potential damage from breaches or accidental privilege misuse. Least privilege should be adopted as the default. It should be combined with need to know and separation of duties. Need to know grants access to the entity that needs to access the data or resource. Need to know limits who has access, while least privilege also restricts what they can do, such as view, edit, or execute. It ensures that even with authorized access, exposure is limited to only the data or functions needed for a specific job. While you may have high access within an organization, you don't need to know, you don't need to be granted access. Separation of duties, split tasks with the potential for fraud or abuse across two or more individuals so that no single user should be able to act without supervision. Limit the number of privilege accounts, which need to be periodically reviewed. The attack surface refers to all points where an attacker could potentially exploit vulnerabilities in a system to gain unauthorized access, cause damage, or disrupt normal operations. It encompasses all the possible avenues through which an attacker could launch an attack, including hardware, software, network connections, network protocols and services, user interfaces, configuration settings, and human factors. Reducing the attack surface is a fundamental principle of cybersecurity risk management. Organizations aim to minimize their attack surface by implementing various security measures, including regular software patching and updates to address known vulnerabilities, implementing access controls and least privilege principles to limit user permissions, using network segmentation to isolate sensitive assets from the rest of the network, employing firewalls, intrusion detection systems, and intrusion prevention systems to monitor and control network traffic, conducting security awareness training for employees to educate them about cybersecurity risks and best practices, implementing multi-factor authentication or MFA to enhance authentication security, performing regular security assessments and penetration testing to identify and mitigate potential vulnerabilities, and implementing secure coding practices and performing code reviews to reduce the likelihood of software vulnerabilities. Trust refers to the confidence or reliance placed on a person, system, process, or entity behave in a predictable and dependable manner, particularly concerning the protection of sensitive information, assets, or interest. Trust is a critical concept in cybersecurity and is essential for establishing secure relationships, communication, and transactions in various contexts, including trust between users and systems, trust between systems, trust in digital entities, trust in third party, trust in data and information, and trust in security mechanisms. Establishing and maintaining trust and security is a complex and ongoing process that involves multiple factors, including transparency. Openness and transparency in security practices, policies, and procedures inspire trust and confidence among users and stakeholders. Accountability. Holding individuals and organizations accountable for their actions and decisions regarding security helps reinforce trust and ensure compliance with security requirements. Compliance. Adherence to industry standards, regulations, and best practices demonstrate a commitment to security and fosters trust among customers, partners, and regulators. Continuous improvement. Continuously monitoring, assessing, and improving security posture and practices demonstrating a dedicated to maintaining trustworthiness and resilience in the face of evolving threats. Ultimately, trust and security is built over time through consistent and reliable behavior, clear communications, and a commitment to protecting sensitive information and assets from unauthorized access, misuse, or exploitation. Zero trust is a cybersecurity concept and strategy based on the principle of never trust, always verify. Think of this as only trust after you verify, don't trust blindly. It means that no one is trusted by default from inside or outside the network, and verification is required for everyone trying to gain access to resources on the network. These added layers of security have been shown to prevent data breaches. Since everything seems to be connected to everything, zero trust is a must. Connectivity to resources are not just confined to a single building. Sites are connected to each other. Users connected to the internet from anywhere. Users using the internet for work and leisure while on or connected to the organization's network. Cloud services are hosted outside of the organization and allows many resources and services hosted by a third party. And contractors and consultants and third-party personnel have access to your network, resources, and services. A gap analysis is used to identify security vulnerabilities. A gap analysis provides insights into the client's existing processes, how they use technology, and what security measures are in place. It will uncover areas of threat, which will allow you to determine if new technology or processes should be implemented, or current technology and/or processes improved or reconfigured that will improve the security posture. To perform a gap analysis, you would determine the scope and desired state, define the current state, identify the gaps, and develop a security roadmap to reach desired state. People, processes, and technology form the three pillars of a balanced, holistic cybersecurity strategy. People have a job to do, and it is the same people that are both the security control and risk. These people are crucial for recognizing phishing and social engineering. It is also people who are responsible for configuring and responding to security threats. Processes turn security from best intentions into repeatable, auditable actions by defining the rules and procedures for security management, including incident response plans, access controls, and compliance. Technology provides the tools such as AI-driven detection systems, automate defense, enforce policies, and provide visibility into threats to monitor and enforce security measures. All three elements, people, process, and technology, need to work in harmony for successful business operations or change management. If one aspect is weak or not aligned with the others, it can impact the overall efficiency and effectiveness. The chain is only as strong as its weakest link. Security is only as strong as its weakest link. Too often, these weak links are the organization's employees. Bad actors usually target an organization's most vulnerable touchpoints to gain access to sensitive data through social engineering and phishing. Other common mistakes employees use is misconfigured systems, misdirected emails, shadow IT software and services, weak passwords and password sharing, and using public Wi-Fi networks. So how do you fix the weakest link? You establish policies and procedures to help direct people. You conduct regular awareness training. Remember, knowledge is power. And users, including administrators and end users, have to be constantly reminded and trained on security. When dealing with security, don't make it too difficult for users to enhance security. Users will rebel and try to find ways to work around it and not use it. Remember, you need to keep everything secure, but they also have a job to do. Security often costs money. You don't want to spend more money to protect something than what you're protecting is actually worth. Security measures have to be cost effective. Technology can be awesome, but don't forget the people and what they need to do their job. To get you thinking about security, you should play the game at the displayed site. An endpoint is any device that connects to a network to send or receive data, acting as the end of a connection. It includes user devices such as desktops, laptops, mobile phones and tablets, servers, IoT devices such as smart thermostats and cameras, network hardware, and virtual machines. Protecting endpoints, such as laptops, phones, and servers, is critically important because they're the primary entry points for cyber attacks and it's the largest attack vector in enterprise IT environments. It often holds sensitive data and acts as gateways to the entire network. With remote and hybrid work, endpoints are the new network perimeter, replacing traditional firewalls that can't protect devices outside of the office. Endpoint protection has traditionally been focused on preventing malware and other known threats from affecting a desktop or laptop PC. Securing them prevents malware, ransomware, and data breaches, ensure regulatory compliance, maintains operations, and protects against threats that bypass traditional defenses, making it essential for businesses of all sizes. Question. Identify the following as confidentiality, integrity, or availability. Answer. Enforcing service level agreements, availability. Implementing a data classification schema, confidentiality. Ensuring encryption for data in transit, confidentiality. Utilizing a formal change in management, availability. Perform a business impact analysis or BIA, availability. Using a checksum on a file, integrity. Question. In security, what does CIA stand for? Answer. Confidentiality, integrity, availability. Question. In security, what does AAA stand for? Answer. Authentication, authorization, and accounting. Question. What is needed for non-repudiation? Answer. Proper authentication, authorization, and accounting have been established. Question. What is the best strategy and implement an effective operational security posture? Answer. Defense in depth. Question. What is described if you have fences, card readers with a PIN to access systems, cameras, security cards, and encryption to protect your assets? Answer. Defense in depth. Question. When accessing a corporate network, you're required to authenticate to each application you try to access. Which of the following does this best represent? Answer. Zero trust. Question. To implement the best security practices for your company to reduce risk, you should do what? Answer. Encompass people, process, and technology. For more information, visit these sites. In summary, everyone is at risk of data breach or cyber attack, no matter how small or how large a company is. Even individuals are at risk. Security involves the protection of information systems and the information processed, stored, and transmitted by these systems from unauthorized access, use, disclosure, disruption, modification, or destruction. Since complete security can never be fully achieved, The focus of security is more often the process instead of the goal. CIA represents a model that represents the core goals of the information security program: confidentiality, integrity, and availability. AAA is short for authentication, authorization, and accounting, which is also known as auditing. Non-repudiation is the assurance that someone cannot deny the validity of something. Defense in depth is a strategy that leverages multiple security measures to protect an organization's assets. Least privilege has each entity, such as a user or service, is granted the minimum system resources and authorizations that the entity needs to perform its job or function. Zero trust security means that no one is trusted by default from inside or outside the network, and verification is required from everyone trying to gain access to resources on the network. A gap analysis is used to identify security vulnerabilities. Security is only as strong as its weakest link. Too often, these weak links are the organization's employees. Thank you for watching this video. The next video will be Network Security Part 2, Risks, Vulnerabilities, and Threats. If you like this video, click the like button, and if you have not already, subscribe to the Pat Hedger Back channel. Thank you.